another interesting video in the math class. And today we're going to be looking at a really interesting and important topic in the arena of linear algebra called as LU decomposition of matrices. So as the name implies, what we're going to do here is we would be decomposing a matrix into two matrices, that is L and U. So A x equals B, right? If that's your system of linear equations. What we're going to do is you're going to decompose this A into two matrices, like A equals L into U, where L is a lower triangular matrix, right? And U is an upper triangular matrix. Okay, so why do we do this decomposition? Because that simplifies our calculations, right? Tomorrow, like in applications like computer gaming or maybe like engineering structures, civil engineering, where large structures and large equations have to be handled constantly, you cannot afford to solve for each of these high coefficients every single time, and that's where your decomposition L into U greatly simplifies computations, right? So let's see how that is done. Let's take a sample matrix and let's see how do we decompose them into L and U. Right, so let me write. Let's take, we have a matrix that's something like this. Like say A equals 2, 1, 1, 4, 3, 3, and 8, 7, 9. Okay. So when we decompose this into L and U, right, it's going to look something like this. Like your L will be something like where this is all going to be 1. This is going to be all zeros because it's a lower triangular matrix. And these are the positions that we need to fill, right? With the correct numbers, okay? And your upper triangular matrix is going to look like this, where you need to have all zeros over here, right? And these values, they're going to be transformed using Gaussian elimination, right? So let's see how we do that, okay? So in order to make this 0, and this 0, we need to perform Gaussian elimination, right? So how do we do that? To make this thing 0, we perform row 2 transforms to row 2 minus twice row 1, right? If you want to know what is Gaussian elimination, watch my separate video on that topic, Gaussian elimination, and that will make things clear, okay? So let's perform row 2 equals row 2 minus 2 row 1. So on this side, which is the upper matrix, we get 2, 1, 1, 0. So 4 minus 4 is 0. 3 minus 2 is 1. And 3 minus 2 is 1, right? 0, 1, 1, all right? Now, remember this coefficient 2 directly comes over here. Why is that so? Because if you multiply this one with this one, right, you should be getting this matrix. That's the idea here. So for obvious reasons, don't you think that this coefficient 2 should be coming at this place? Okay, so that's what we are doing. Now to transform this thing to 0, what do we do is, we do row 2 transforms to row 2 minus 4 into row 1. Okay? Because 2 into 4 is 8. Okay, so 4 into row 1. So let's perform that calculation. So this becomes 0, 3, and 5. Correct? Okay? And then this coefficient obviously comes at this position, right? Because this row has been multiplied by 4 times this row. So put this coefficient here. And then, now to make this 0, what we do is, we perform row 3 transforms to row 3 minus thrice row 2. Okay. So let's rewrite this for a moment. So like 1 0 0 2 1 0 4 1 into 2 1 1 0 1 1. And if you perform this, what you get is 0 0 2. Correct? And then this coefficient 3 will come in this position. Okay, because that's what we have transformed. So this is your L matrix and this is your U matrix. And if you multiply these two, L into U, you will get this matrix. Just try this out. Okay. I'll leave this to you. Okay. So that's the way you perform an LU decomposition. Does this make sense? Okay. So how do you solve a system of linear equations using this LU decomposition? So you have your AX equals B, right? So now your A has been decomposed to L and U. So now this transforms to LUX equals B. So what you do is you substitute for UX equals Y, and then solve for LY equals B. All right, so you get your Y1, Y2, and Y3, right? So using these Y1, Y2, Y3, substitute them back here, and then solve for X, okay? So UX equals Y, so that gives you your X1, X2, and X3, okay? So that's how you solve this system of linear equations, all right? I hope that's clear, right? So that's it. That's LU decomposition for you. I hope that is useful. So yeah, this is how you perform LU decomposition, and that's one of the methods of solving a system of linear equations. If you like this video, please hit a like button at the bottom and then subscribe to the channel. And until then, I wish you all the very best for your preparation and see you in the next class. All right, I'll see you in the next class with another video. Until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.